The objective of this video is to practice writing equilibrium expression and solving simple problems involving chemical equilibrium. Right, the first question you have nitrous acid ionization in water. So in this question it actually says you have water as a solvent and it is not even included in the equation in this given equilibrium equation. And it says at equilibrium the aqueous nitrous acid has this given concentration at equilibrium. So not what it says. So you might want to read very carefully when it comes for these questions, whether it is talking about the equilibrium or any other reversible point. So now this says it is at equilibrium, so you can comfortably write the expression for equilibrium constant. And it has given what is present, the concentration of reactants and products at equilibrium. The concentration of H plus is 0.014 mole and you have NO2 concentration and HNO2 concentration. Now go ahead, pause this video and write the expression for equilibrium constant. Your expression is the concentration of the products divided by the concentration of reactant. Now go ahead and substitute these numbers for the concentration of H plus, the concentration of NO2 minus, and the concentration of the remaining acid HNO2. And this will be the answer you get. And what do you think the unit should be? The units of this equilibrium constant. Now keep in mind, based on the type of equilibrium expression you get, your units can change. Right. Now you get the concentration in terms of mole unit. Now that would be the units of your equilibrium constant, and this is the numerical value. Now the second part of the question asks, does this equilibrium favor reactants or products? How are you going to find that out? Now look at this numerical value you have obtained. Is it larger than 1 or is it smaller than 1? You can obviously see this. This is a 10 to the power negative number. So this is going to be a smaller number than 1. What does that mean? When we write the equilibrium expression, this is product concentration divided by the reactant concentration. So what kind of a situation will give you a number smaller than 1? If you have more product, or more like a large number, and as the denominator, if you have a small number, what will you get? That will result in a large K. So if you want to end up with a small k, then your denominator needs to be larger. So that means if you have a small number divided by a large number, then you will have a small k value. So that means if you have more reactants, you will end up with a smaller k. So as you have received an answer that is less than 1, that means your denominator is larger. That means you have more reactant. If you have more reactant, that means at this equilibrium actually favors reactant. So what is present more at this equilibrium point? the reactants. It favors the reactants. The next question. You have hydrocyanic acid dissolved in water to produce H3O plus and Cn minus, and you are provided with the equilibrium expression. And you're given the equilibrium constant for the reaction, and you are provided with the concentrations of H3O plus and Cn minus, and it is asking for the concentration of HCN. Now again, pause this video and write the equilibrium expression, because we are given the information that this system is at equilibrium by the time that we use all these numbers. Alright, this is going to be your equilibrium expression. You can find the product H3O and Cn minus as the numerator and HCN as your denominator, and you can see the water. How do you know it is a solvent? The description says it. The hydrocyanic acid, which is this, is dissolved in water, so that way you know this is your solvent. And because it is the solvent, you do not include it in the equilibrium expression. Alright, once you write the equilibrium expression, now you have to rearrange the equation, because in this question you are trying to find the concentration of HCN. So rearrange this equilibrium expression until you get this second expression. Now go ahead and substitute the numbers from the given in the explanation. Once you do the calculation, you will get the concentration of HCN. Another example. Now in this example, when you read, you will find the information given in partial pressures. Now this explanation doesn't give any concentration values. What it gives are the partial pressures that is observed at equilibrium. So this reaction, methane water reaction mixture, result in hydrogen gas and carbon monoxide. Now this reaction is at equilibrium, and you are provided with the equilibrium constant, so you can consider this actually as Kp, because we are using partial pressures. Now you can go ahead and write the equilibrium expression. Now you might be wondering why we included the partial pressure of water in this expression while we did not include that in the previous example. Now in this description, what it says is that H2O is not actually a solvent, it is a reactant. So it is actually reacted chemically with methane to produce hydrogen gas and carbon dioxide. So in the case it is used as a reactant, we have to include it in our expression. Another thing, note the physical state. Usually when water is present in gaseous state, we include it in our equation. Usually it is the liquid form that we do not include, because the liquid form is most often used as a solvent, whereas this steam or water in the gas form is used as a reactant. Now in here, water is an actual reactant, so we have included that in our expression. Now you have written the expression. What you are required to find is the partial pressure of carbon monoxide. So that means what you have to find is that. Now go ahead and rearrange the equation. Once you rearrange, your setup is going to be like this. Now go ahead and substitute the numbers. You have the K value, which is this. And then you have all the partial pressures you require for your calculation. And once you solve the problem, you can find your answer in pressure units.